For CSIT314, we have developed a testing tool for sorting algorithms. Our test oracle is the validity and the efficiency of sorting algorithms. We have designed this testing tool to be extremely flexible by supporting generic types. This means our testing tool supports sorting algorithms for numbers, strings, and even objects, provided they can be sorted and compared. We will test bubble sort for this example, but our source code contains examples for 5 other algorithms. To get started, we first need to create an instance of our testing tool in our code. It is giving us an error because it requires 3 arguments. First, a sorting algorithm, secondly, a compare function, and third, a generate function. This first function is our sorting algorithm. It must adhere to this interface containing an argument for an unsorted array and a compare function, or else it won't work. The second function is the compare function. This function takes 2 arguments and compares them, returning -1 if the first is less than the second, +1 if the first is greater than the second, and 0 if both values are even. Finally, the third function is a generate function. This function must take a number as input and predictably generate a value of our generic type as output. For instance, if our generic type is a string, we could generate the value A from the input value 1, B from value 2, etc. It is important that values that are output from this function are ordered and use the same ordering logic as the compare function. Once we have written each of these functions, we can call a set efficiency method on the testing tool object. By doing this, we have set the approximate efficiency of this sorting algorithm. For bubble sort, this is n squared. After this, we can queue up tests for our testing tool. This method takes 2 arguments, test type and array length. Our options for test type are as follows: random, shuffled, pre-sorted, reverse sorted, and empty. This allows us to test with random data and edge cases. If we need to change the efficiency of the algorithm for different test types, we can do so. Once we are happy with the tests we have queued up, we can call the run tests method. This method will start the process of generating our random arrays and testing them against our criteria. There are 3 criteria we have laid out. First, we check that the length of the sorted array is the same as the original array. Then, we validate that the array has been sorted correctly. Finally, we validate that the algorithm operates with our anticipated efficiency. Since our testing tool is written in the same language we are testing in, it is really easy for users to abstract our testing tool further based on their needs. One way of doing this could be by randomizing array length. Another could be creating a suite of tests once and automatically running the same tests for different data types. The sky is the limit here.